Welcome, everyone. Today marks the start of our exploration of Java. We'll build your knowledge step by step, starting with the core basics. Let's jump right in. Java is a high-level, object-oriented programming language that's designed to be simple, secure, and portable, which means you can write your code once and run it anywhere, as long as there's a Java virtual machine installed. It uses the concept of classes and objects to help you model real-world things in your programs, making your code more organized and reusable. Because Java compiles your code into something called bytecode, it doesn't matter what operating system you're using, Windows, Mac, or Linux. The JVM takes care of running it the same way everywhere. That's why Java is so popular for building web applications, Android apps, and big enterprise systems. The Java Virtual Machine, or JVM, is a part of Java that lets you run your Java programs on any computer without changing the code. It works like a translator between your compiled Java bytecode and your computer's operating system. When you write Java code and compile it, it turns into bytecode that the JVM reads and converts into machine code that your computer can understand and execute. This is why Java is called platform independent. The same program can run on Windows, Mac, or Linux, as long as there's a JVM installed to do the job. The JDK, Java Development Kit, JRE, Java Runtime Environment, and JVM, Java Virtual Machine, are three parts of the Java platform that work together. The JDK is what developers use to write and compile Java programs. It includes tools like the compiler, debugger, and the JRE. The JRE provides everything needed to run Java programs, including the libraries in the JVM, but doesn't have development tools. Finally, the JVM is the part that actually runs the compiled Java bytecode, turning it into machine code that your computer understands. So, you use the JDK to write Java code, the JRE to run Java applications, and the JVM is the engine that makes it all work on any system. In Java, an object is a basic building block that represents a real-world thing or concept in your program. For example, a car, a student, or a bank account. An object is created from a class, which acts like a blueprint. Each object has properties, called fields or attributes, that describe its state, and methods, functions, that define what it can do. For example, a car object might have properties like color and speed, and methods like drive or brake. By using objects, Java makes it easier to organize code and model real-life situations in a clear and reusable way.
In Java, a constructor is a special block of code that runs when you create a new object from a class. Its main job is to set up the object with initial values. A constructor looks like a method, but it has the same name as the class and doesn't have a return type. For example, if you have a car class, the constructor can set the car's color or model when you create it. If you don't write any constructor, Java automatically provides a default one for you, but you can also write your own to control how objects are initialized with specific values right when they're made. Method overloading in Java means having multiple methods in the same class that share the same name but have different parameter lists, different number or type of arguments. It's a way to let a method perform similar tasks in different ways. For example, you might have a print method that prints an integer and another print method that prints a string, both named print but with different parameters. When you call the method, Java figures out which version to run based on the arguments you provide. Method overloading makes your code more readable and flexible because you don't need to use different method names for similar actions. Inheritance in Java is a concept that lets one class reuse the properties and behaviors of another class, making it easier to write cleaner and more organized code. Inheritance works by creating a parent class, also called a superclass, with common fields and methods, and then a child class or subclass that extends the parent class to get all its features plus any new features of its own. For example, you might have a vehicle class with basic properties like speed and a car class that inherits from vehicle but adds extra things like air conditioning. This helps you avoid repeating code and makes it easier to manage related classes. In Java, double equals and dot equals are both used to compare things, but they work differently. The double equals operator checks whether two references point to exactly the same object in memory. so it compares locations, not contents. On the other hand, the dot equals method is used to check whether two objects are logically equal, meaning they have the same values inside. For example, if you have two different string objects that contain the same text, equals equals will return false because they're different objects in memory, but dot equals will return true because the text inside is the same. So, for comparing primitive types like int or char, equals equals works fine, but for comparing objects, it's usually better to use dot equals if you want to check the actual content.
In Java, access modifiers are keywords that control where your classes, methods, and variables can be accessed from in your code. There are four main ones: public, private, protected, and the default. If something is public, it can be used from anywhere in any other class or package. Private means it can only be used inside the same class. This is good for hiding internal details. Protected allows access within the same package and also by subclasses, even if they're in different packages. If you don't write any modifier, called default or package private, it's accessible only within classes in the same package. Using access modifiers helps you protect your code, hide unnecessary details, and keep your program organized and secure. In Java, an interface is like a contract or blueprint that defines what a class should do, but not how it does it. An interface only contains method signatures, like void and doesn't have any method bodies, though modern interfaces can also have default and static methods with code. When a class implements an interface, it promises to provide the actual code for all the methods declared in that interface. Interfaces are useful because they let you achieve abstraction, hiding the details, and multiple inheritance in Java. A class can implement multiple interfaces, allowing it to follow multiple contracts. For example, you might have an animal interface with a method makeSound, and both dog and cat classes can implement it in their own way.